is 4.7. It is our last section in Module 4. This is going to be applications of logarithms and exponentials. So there is a formula that we need to know for this first question, and that is A equals P times 1 plus R over N to the Tn. And so let's define everything there. A is the amortized amount, or the amount after time. P is my principal or initial amount. R is my rate as a decimal. T is time in years. And N is my number of compound cycles per year. So I always like to take a second and talk about N real quick. If N is semi-annually, that means 2. If N is annually, that means 1. I forgot an N. Annually, that means 1. Monthly would then be 12. Weekly would be 52. If you see quarterly, that would be 4. And daily would be 365. Okay. And then if you see the word compounded continuously, it's literally right in front of me and I can't spell it. You would use a different formula, and that's A equals PE to the RT, where A, P, R, and T are all the same things that I just said. I know Andy goes over all that in his notes, but I like to review. So here, annually would mean if we have, so first of all, we have 16,400 is my principal at a rate of 10%. So R is 0.1. The value of the investment after 9 years. So T is 9. Okay. And that's going to be every time for all of these. So annually then, N is 1. So I have A equals 16,400 times 1 plus 0.1 over 1 to the 9 times 1. I'm putting that right in my calculator. Now, if you have a TI-83, when you press that caret button to do your exponent, make sure that you put parentheses around 9 times 1. It obviously doesn't matter when it's 1, but when it's something else, it will. So $38,670.34. $670.34. So then semi-annually, N is 2. So now A equals 16,400 times 1 plus 0.1 over 2 to the 9 times 2. So if you have a TI-83 and you don't put parentheses around your 9 times 2, It's going to take your thing, do it to the 9, and then multiply that by 2, and you're going to get the wrong answer. 39, 46, 56. 39, 468, 56. Monthly N is 12. So we have 16,400 times 1 plus 0.1 over 12 to the 9 times 12. $40,187.34. Weekly N is 52. $43,02.64. Daily N is 365. $43.32. 332.52. And then continuously would be A equals P 16,400 E to the 0.1 times 9 E. Oop. Really? There you go. E to the 0.1 times 9. 337.49. Okay. That was a long one, but worth going over. Okay. How much would you need to deposit into an account now? So I'm looking for my principal. In order to have $3,000, that would be my amount after time. And in the account after 10 years, assume it earns 4.7% interest compounded weekly. It says that over there, weekly. So back to my formula from above. So this would be 3,000 equals X times 1 plus 0.047 over 52 to the 10 times 52. So I'm going to put this in my calculator. 1 plus 0.047 over 52, oops, to the 10 times 52. 1.56. Then I'm just going to do 3,000 divided by that. That's second, and then your negative sign. Answer is the last thing. So 1875.40. How much would you need to deposit now? So this is another case where I'm looking for P. There's more. Baby. In order to have $5,000 in your account after 10 years, assume you earn 2.7% interest compounded continuously. Means I need my PE to the RT formula. So 5,000 equals X times E to the 0.027 times 10. So again, remember E is a constant, so this is just a number. So E to the 0.027 times 10. 1.31. And then let's do 5,000 divided by that. So 3,816 and 90. That should have been an X. How many years would it take? So this time T is my X. For an investment of $4,300, so that's my principal, to grow to $7,900, so that's the amount I want to have after time, at an interest rate of 4.7, so R is 0.047, compounded weekly, so N is 52. So let's fill this in. 7,900 equals 4,300 times 1 plus 0.047 over 52 to the 52x. Okay. I want to know what this is. I want a better thing than that ugly. 1 plus 0.047 divided by 52. 1.0009. Bless you. Now I'm going to divide by 4,300. I hear you. It's all done. You got to give it a minute and it'll be right back. 7,900 divided by 4,300. 1.837. Anytime you have a variable in your exponent, turn it into a log. So this would be log with base 1.0009 of 1.837 equals 52x. I'm going to figure out what this is. The log of the last thing I put in. Oops. the log of the last thing I got divided by the log of 9. And divided by 52. 13 years. 2 decimal places would still be 13 years. So anytime you are looking for your time, you're going to wind up having to turn your equation into a log. Okay. Find how many years it would take for your money to double. So T is X, for your money to double when invested at an annual interest rate of 0.65. Compounded continuously means I'm going to use my PE to the RT. So anytime they ask you for a doubling amount, you can plug in a number. Like you can say, well, if I started with 100, then I would end with 200. Or you could say, well, if I start with P, then I want to end with 2P. And you're going to see that in the end, the same thing's going to happen no matter what you plug in. So let's just say I'm starting with $1. So that's my P. So then my A would be $2. I'm picking the easiest numbers I possibly can. And you can do this every time you have a question that's asking you about doubling. Make P1 and A2 because that's double. You could make P50 and A100 because it's double. You can plug in anything you want here as long as your A value doubles your P value. Okay, so we needed PE to the RT. So 2 equals 1E to the 0.065x. Now, if I divided both sides by this 1, I would just have a 2 here. And if I had had a 50 here and a 100 here, I would have divided both sides by 50, and I would have wound up with a 2 here. If I had had a million here and 2 million here, I would have divided both sides by a million, and I would have ended up with a 2 here. So no matter what numbers, if I would have said P and 2P, I would have divided both sides by P, and I would have ended up with a 2 here. No matter what you plug in here, as long as you plug in double, this is where you're always going to end up. You're always going to end up with 2 equals, and then e to the 0.065x. And so now doubling down on what I said before, anytime you're looking for time, you're going to have to turn this into a log. So this would be log with base e, which is the ln of 2 equals 0.065x. So then the ln, my calculator turned off right then, the ln of 2, 0.06, 0 point. So 0.6931. And then we're going to divide that by 0.065. So it would take 10.66 years. Okay. If it takes 7 years for money to double, so that again, we're going to say P is 1 and A is 2. In an account that is compounded continuously, how many years will it take for the money to triple in that same account? So I'm missing R. So let's figure out what the rate on this account is. So 2 equals 1e to the 7r. But that's just 2 equals e to the 7r, right? So then that would be the ln of 2 equals 7r when I turn this into an exponential, log with base e of 2 equals 7r. So then we need the ln of 2, which we did just figure out a second ago, this time divided by 7. So my rate is 0.099. 9.9%. So then how many years will it take to triple? Okay, so this time I don't know t. This time my p is 1 and my a is 3, because now instead of doubling, I'm tripling. And my r is 0.099. So 3 equals 1e to the 0.099x. But again, 1 times anything is just that thing. So now I have log with base e, or the ln, of 3 equals 0.099x. So the ln of 3, and then divided by 0.099. So if it took 7 years to double, it'll take 11.1 years to triple. One of the other things that Andy talked about in these notes is something called an effective rate. So the effective rate is the earning in a year, and it depends on the number of compound cycles in that year. So your effective rate is 1 plus r over n to the n minus 1, where r and n are exactly what we talked about before. That is rate and the number of compound cycles per year. And if you compound continuously, then your effective rate is e to the r minus 1. Okay, so find the effective rate of an account that earns 5%. So for all of these, we're going to say r is 0.05. Semi-annually means that n is 2. So then my effective rate would be 1 plus 0.05 over 2 to the 2 minus 1. So that would be 0.0506. They want 4 decimal points, and they want it as a percent. So then this would be 25. So it would be 5.0625%. Quarterly, n is 4. So my effective rate is 1 plus 0.05 divided by 4 to the 4, and then minus 1. So 5.0923400945. Monthly, n is 12. So my effective rate is 1 plus 0.05 divided by 12 to the 12, and then minus 1. So that's 5.1234. Weekly N is 52. To the 52. Five point. And then continuously equals e to the 0.05 minus 1. I don't know that it was necessary for me to do every single one of those, but I did. Okay. The number of bacteria in a culture is given by the function 900 e to the 0.035t, where t is measured in hours. What is the relative percentage growth rate? So that's going to be my, since this is an E formula, it's going to be the R e to the 0.35 minus 1. So that would be 41.9068%. The initial population is always this number in front, so that's 900. Because when time is 0, this would be e to the 0, which is 1 times 900. Okay, and then how many bacterium will there be after 4 hours? .35 times 4. $36.50 bacteria. The population of a city in 2010 was 4.9 million. Growth rate estimated at 2%. Assuming the city's population follows an exponential growth model, Find the projected population in 2026. Sorry, writing was so small. So we'll use 2010 as my initial year. So then my population would be 4.9 e to the 0.02 x. That would be my function. And we want to know from 2010 to 2016 to 2000, from 2010 to 2026 is 16 years. So 6.75 million people. A bacterial culture initially contains 2,000 bacteria and doubles every half hour. Find the bacteria after 60 minutes. Okay, so we have 2,000 E doubles would be, it increases by 100%. So 1. So how many times would it double in 60 minutes? That's what you need to ask yourself. So if it doubles every half an hour, then this means that it doubles twice. So we would say 2,000 e to the 2. Not e. When you're talking about doubling, your base is 2. 2 to the x. I had e stuck in my head. So then 2,000 times 2 to the 2 because it doubles twice. $8,000. And that makes sense. From 2,000 to 4,000 in the first half hour, from 4,000 to 8,000 in the second half hour. After 4 hours, well, after 4 hours, you would have doubled 8 times if you're doubling every half an hour. So then that means we need 2,000 times 2 to the 8. Now, a note that this is 2 because it's doubling. If they would have said tripling, this would have been a 3. If they would have said quadrupling, this would have been a 4. Okay? If they would have said that the population gets cut in half every half an hour, I would have made this a 1/2. Okay? The doubling time of a bacterial population is 15 minutes. After 110 minutes, the bacterial population was 7,000. Okay. So I know that when X is 110, I get 7,000. So I'm going to say, I need to know the initial amount. So I'm going to say 70,000, excuse me, right? 1, 2, 3, 4. 1, 2, 3, 4 equals 100. No, equals X times 2. Now this is where we're going to get tricky. 110 minutes, but I need to know how many times did it double. If it doubles every 15 minutes, then this is to the 110 divided by 15. Because we have a total of 110 minutes, doubling every 15 minutes, this will give me how many times does it double. I hope that makes sense. So initially I had 434 bacteria. So then that would be my initial 434. I want my phone. And then after 3 hours, well, if it doubles every 15 minutes, then in 3 hours, it would have doubled 12 times. Okay. A bacteria culture starts with 880 bacteria and grows proportional to its size. After 6 hours, there will be 5,280 bacteria. So express the population P of T. So we need to know the rate here. So this time, since it's not doubling, I'm going to go back to E. So starts with 880. After 6 hours, we have 5,280. So 5,280 equals 880E to the 6R, because I'm looking for my rate. Divide both sides by 880. So then the ln of 6 equals 6R. So the ln of 6 divided by this 6, and my rate is 0.2986. Say round your answers to 3 decimal places, so 299. So I would say P of T equals my initial amount, E, to the 0.299 T. I'm going to write it over here too. So then after 2 hours, well, we would say 880E to the 0.299 times 2. And your answer to 3 decimal places, 1,600. 261. And then how many hours will it take to reach 1730? So 1730 equals 880e to the 0.299t. Divided by 880. So then the ln of 1.966 equals 0.299t. Of what I just had, divided by 0.299. 2.261 hours. It's a lot of like different types of questions in these notes, huh? The half-life of radium-226 is 1,590 years. If a sample contains 400 milligrams, how many will remain after 400 years? 4,000 years, excuse me. So that means we need to know at what rate is it decreasing? Oh, no, we don't. So here we would say it's a half-life. So I would say that my initial amount is 400, and then it's a half-life. So my base is a half. Just like before when we doubled, my base was 2. This is a half-life, so my base is a half. And then 1 half-life is 1,590 years. So remember before how I had to do 110 over 15? Here I have to do the 4,000 years over 1,590 years, because that will tell me how many half-lives have we gone through. $400, 1/2 to the 4,000 divided by 1,590. 2 decimal points. The half-life of palladium 100 is 4 days. After 16 days, a sample has been reduced to 5 milligrams. What was the initial mass? Okay. So our end amount was 5 milligrams. We don't know the initial amount, but we know it's a half-life, and we know that we had 16 days, and each half-life is 4 days. So how many half-lives was that? Well, that one's easy. It's 4 half-lives. So what is 1/2 to the, so 0.0625, and then 5 divided by that, 80. So my initial amount was 80 milligrams. How many are left after 6 weeks? How many days are there in 6 weeks? 42. So then we would say half, 80 times 80 is my initial, half and then 42 days over 4 to figure out how many half-lives will happen, since one half-life is 4 days. Five decimal points. 1, 2, 3. There we go. A wide variety of questions in these notes. Why is this being like this? Okay, let me try something. It's like literally being super weird whenever I try to stop recording. There we go.